Elements. Elements are all around us. They're in the water we drink and the very air we breathe. Inside each element are energy levels that consist of different numbers of electrons. The electrons in the outermost energy level are called valence electrons.
Valence electrons bond may either form ionic or covalent bonds. An ionic bond occurs between oppositely charged ions which form when electrons are transferred from one atom to another. Covalent bonds occur when elements share one or more valence electrons.
When elements bond, they form compounds or substances. To write these new compounds down, scientists decided to write them as chemical formulas such as H2O, water. When compounds are not chemically combined, they make mixtures. A mixture is two or more substances, a combination of them, not chemically combined. For example, a pizza. A pizza is a combination of pepperoni, bread, tomato sauce, and jalapeno, and bunches of other toppings, all layered together to make a new substance. There's no big experiment, no big explosion, no pepperoni slices turning into bizarre colors, just a simple pile of substances to make a new one. A bowl of salad. It consists of lettuce, tomato, more lettuce, ranch, more lettuce, croutons, more lettuce, and bunches of other stuff, all churned together to make a bowl of salad, something new. This box of crayons is a mixture. It consists of the purple crayon, the orange crayon, the yellow crayon, and all other colored crayons, all put into one box to make a box of crayons. Mixtures are everywhere. Now let's go to a moment with Dijon.
Hello, welcome to A Moment with Dijon. Today we are learning about chemical change. Chemical changes occur when one or more substances change into entirely new substances with different properties. The change can either be an exothermic reaction or an endothermic reaction. An exothermic reaction is when heat is released. An endothermic reaction is when heat is taken in. Thank you and goodbye.
To represent chemical reactions, scientists use chemical equations that use symbols to show the relationship between the reactant and the products. An example of this is C plus O2 yields CO2. According to the law of conservation of mass, what you start with, you end with.
The law of conservation of mass is the law that states that mass cannot be added nor destroyed in any ordinary chemical or physical change. For example, have you seen the movie Transformers, right? Well, if you haven't, go watch it and you'll know what I'm talking about. Well, you see a car, right? Just a regular, normal car, and it transforms into this big fighting machine. And you think, how did that big thing come from that car? I mean, the machine's got to weigh a couple tons more at least. But it doesn't. It weighs the exact same as the car. Nothing is created or destroyed, just rearranged. For example, you see this piece of paper, right? It's long, nice, thin, and large. Well, what happens if I fold it? And then I fold it another time, and another time, and one more time. And you've got something that's much smaller than it originally was. You think, that's gotta weigh a couple ounces left. I mean, lower. I mean, just look at that. It's just so much smaller than what it originally was. But it's not. It weighs the exact same thing. What you start with, you end with. It has the exact same mass as it originally was just 10 seconds ago. Nothing is created or destroyed, just rearranged. For example, if the Earth was to be sucked into a black hole, not crunched in, just all together, the Earth going in to a black hole intact, it would be crushed to the size of a golf ball. But it'll weigh the exact same. Holding it in your hand, you'd be holding the mass of the Earth. Nothing is created, no mass is destroyed, all the mass is still in there, holding it in your hand. This is the law of the conservation of mass.